All right, we ran out of time in the last one, so here's where we are at the point where we added the resultant of this and this. I'm going to even get rid of that. Remember, we had the whole point of having the xref underneath. This was our result, and we slid it to the point of concurrency with the reaction in the y direction, and now all we've got to do is do an x line from the endpoint there, right, to the endpoint there. Now that x line does not add, those just act weird. I'm sorry. So I'm going to give it then a line of force, a geometric line of force or a reactive force line from the endpoint here to the endpoint there, right? In other words, these are my lines of force, so we're going to pick a direction home. My direction home is up, and I'm going to go two ups. In other words, I'm coming down with this force. I got to get to the up direction through this line of force. Left click, space bar, C for copy to the end point there. And again, what you do then is you sketch on top. So when you sketch on top, by doing this, you're going from here to here was your result. And remember, it was down, and this is what it became. You're coming down, then you're going to go back and then up. So how do you do that? You put it on the right layers. Force reaction, you draft a line from the endpoint there to the intersection, and then back up, and you bemoan the fact, back up basically to zero there, you bemoan the fact that you didn't put those on the right layers, but by going left click, putting them on force reaction, you can now go ahead and move them to the right places. So spacebar, left click, spacebar, C for copy, because it just makes it a little bit easier from the endpoint there, right? That is one of your reactive forces. And the other one is left click, grab, left click, spacebar, C for copy. That one, of course, goes to that point it was placed, which is at the quadrant, because you've lost a couple of things. Your reactions now are all done, right? You don't need that. You don't need that. You don't need that. You don't need, you do need that. You don't need this, this, or this. You solve for your reactions. And in the end, your check, if you remember the 9.8, would be that all these add together. So you would add that one, and this one, and this one, and this one here, and add them together. We're going to move on to the next problem. Again, you're learning the draft on top. This problem here, it's a little bit more difficult, right? In some ways not. This problem is better off done, I would say, by solving a reaction for this load and a reaction for this load. That said, let's go ahead and put the things on the right layers to start. Force, concentrated. Remember, you want to draft in the direction of the line of force. I'm not sure that I did that in all my cases, but you would want to check. That's one force there. We have a distributed applied. This is a distributed force, and then we're going to need to go ahead and fix it. Let's just see if B poly works here. Sweet, not. Yeah, it is. List. That is 7.68. So now I can do a line from the midpoint down at 7.68 angle to 70. Right, so I don't need that anymore. Now I've got basically something that I can weight average. That should be on a distributed apply. That makes sense. Right? And so this is coming down and this is coming down. How you add those up? Well, I'm going to put this off to the side, copy this over here. I'm going to copy this from the endpoint here. I'm sticking it over to the side right now just to kind of so you can see it, endpoint. Now we know that's its magnitude, and we know it's based on a weighted average. So your guessing would be it's about there. Now the mathematics of that and the graphics of that, I'm not completely convinced it can be done graphically, but it usually can. What you could do is take out your calculator and go ahead and do the calculation of this force times distance divided by the sum of these forces will get you to the distance to the reaction. I'm going to point out this problem cannot be then done by the concurrent, the three concurrent force rule, because these forces are not concurrent. You do this by what? Distance from another support, distance between the support, distance from the other support, distance between the support, and then back the same way. Or in fact, by taking these two vectors, and I'm just going to graphically put them in their approximate spot. I'm going to go left click, spacebar, C for copy. I'm going to guess it's somewhere not in the middle, and this is about twice as long, so I'm going to go it's about right there. And I'm just going to leave it at that. Next problem. Again, learning how to use the layers. We're going to go ahead and draft over the force concentrated line from the endpoint to the endpoint. Line from the endpoint to the endpoint. We're going to try to do this one as well. And what layers should those be on? They should be on concentrated forces, force concentrated. That said, remember how you can left click, spacebar, C for copy, and you can extend out, and I think you can extend out here until it finds the natural extension. In other words, that is your first force. Now you can left click, spacebar, C for copy, take that to the endpoint. Remember, you take it here, but then you're taking it there because you're doing the reaction. Now you can go ahead and do a force resultant. You can draft a line in the right direction from the endpoint there to the endpoint there. You don't need those anymore. You don't even need these anymore. What you do need, however, is a line of force that is perpendicular to here. You learn to draft things like this. Line from arbitrary, perpendicular to. You then could do things like, well, I want a line of force, and so I can draft on top of something. I'll use the X line from the endpoint here to the endpoint there. I now have my line of force. I'm erasing a window. Why do I have my line of force? This is going to be the point of concurrency right here. So I'm going to left click, spacebar, C for copy, and I'm going to try to grab that extension until it grabs up to there. I've got that. That, of course, gives me another line of force. That gives me the line of force from this reaction up. So I really don't like those X lines all the time, so I'm going to go ahead and draft a line from the endpoint there, hoping I get the right one, to the endpoint there. Zoom in. That one looks correct. That one looks correct. What does that tell us? Well, we're starting here. We're going here. We have to pick a direction home. I'll pick this direction home, and I've got to get to this direction by this direction here. So I can left click, spacebar, C for copy, to the endpoint here. I now have my two reactions. One is going to be along this line of force, and the other one is going to be along this line of force. I put them on the correct layers. Force reaction. Don't want to do that. That's supposed to be a line of force. So what I want to do is I want to put things on the right layers. Force reaction, a line from the intersection here to the intersection there to the intersection there. And once again, we have our forces, and they are, in other words, this force from here to here means that when I left click spacebar, C for copy, I need to put that, so that is the force back in that direction. And this one here, left click spacebar, C for copy, take it to the endpoint right there. Those are my reactions. I can once again, depending, you can go through and get rid of all this stuff. And in this one, I'll finish up to show you what your check can be, even though it shouldn't need to be. You add these vectors tip to tail, so I'll once again put force applied, force concentrated over the top from the endpoint there to the endpoint there. and a line from the endpoint here, and this is an odd check, but it will work. You have to realize you're not allowed to move just vectors anywhere. But if you think this goes up, we're going to left click spacebar. We're not going to copy, we're just going to move to the endpoint. Remember that one is going down. Now I can left click spacebar. I'm not going to copy, I'm going to go to the endpoint there, and I'm going to left click spacebar. I'm not going to move, I'm not going to copy, I'm going to go to the endpoint there, and we see our forces add up to 0. Thanks for listening. I'll just stop with that. I'll continue later. Thanks for listening.